This video is about solid of revolution, and here I have this yellow region right here, and I'm going to revolve it about the line y equal to 4, and we want to find the volume of the solid of revolution. This is the yellow region that we want to rotate, so the function here is 2 times the square root of x plus 2, and we're going to rotate this yellow region about the line y equal to 4. So this is the line y equal to 4. So let's revolve it. And we get a solid that looks like this. And again, what we want to do is find the volume of this solid. And so we're going to find the volume of this solid by dividing it into many slices. For example, here I divided the solid into 8 slices, and so the thickness of each slice will be 1. The distance from here to here is 1 to 9, and so it is a distance of 8, and we're dividing it into 8 subintervals or 8 slices, and so the length of each subinterval or the thickness of each slice will be 1. And again, this can be found by b minus a over n. And then if we divide the solid into 16 slices, then the thickness, or delta x, will be 0.5. And here I'm dividing it into 32 slices, and so delta x, or the thickness of each slice, will be 0.25. And then here I'm dividing the solid into 64 slices, and so delta x, or the thickness of each slice, will be 0.125. And eventually what we want to do is divide the solid here into many slices. So here I divided it into 1,000 slices, and this is the thickness. And here's 100,000 slices, then the thickness of each slice will be 0.00008. And then here I'm dividing it into 1,000,000 slices, so the thickness of each slice will be 0.000008. But now let's go back to the case where I divided the solid into 8 slices, and then therefore the first slice will be between the interval x equal to 1 and x equal to 2. So let's call the first point here, let's call it x sub 0 and then x sub 1. So the midpoint will be 1.5. The second slice will be between x equal to 2 and x equal to 3. And so the midpoint will be and denoted as x sub 2 star, will be 2.5. And then all the way up to the last interval, which is between x equal to 8 and x equal to 9. And that's going to be x sub 7 and x sub 8. And therefore the midpoint of the last subinterval here, which is x sub 8 star, will be 8.5. And to estimate the volume of each slice, we're going to find the what's called the corresponding cylinder for each slice by using the midpoint here, and then find the volume of each corresponding cylinder, and then add the volumes together. And then that will give us an approximation for the volume of this solid. So for the first slice, we're going to estimate it with this cylinder right here. The cylinder is going to be between x equal to 1 and x equal to 2. And then for the second slice, it will be the cylinder between x equal to 2 and x equal to 3. And then all the way up to the 8th slice, which is between x equal to 8 and x equal to 9. And now let's go back to the first one and see how we're going to find the volume of the first cylinder. The first slice is between x equal to 1 and x equal to 2. And so the midpoint is 1.5. And so the thickness of this cylinder will also be 1, just like the thickness of the slice. Now to get the radius of this slice, because we need the radius, because to get the volume of a cylinder, we need the radius and we need the height of the cylinder. Well, the height of the cylinder is just the thickness of the cylinder. To get the radius of the cylinder, we're going to use the midpoint. And so right here, this is 1.5, and so the radius will be the distance from the axis of revolution up to the graph of f of x equal to 2 times the square root of x plus 2. And so to get the this radius right here, we're going to do f of 1.5, and so we're going to do 2 times the square root of 1.5 plus 2. And now f of 1.5 is going to be the distance from the x-axis to the graph. But the radius is only this part, and so we need to do f of 1.5 and then minus 4, subtract 4, and that will give us this radius. And that's what we have right here. And so f of x of 1 star, which is the midpoint, is going to be the distance from the x-axis up to the graph. And then minus 4, and then that will give us the radius for the first cylinder. And then once again, the height of the cylinder, or the thickness of the cylinder, is just 1. And then the volume is just going to be pi times the square of the radius times the height. And so we're going to do pi, which is 3.14, times the square of the radius, so it would be 0.44949 squared, and then times the height, which is 1. And that will give us 0.63473. And so for the first slice, we can estimate it with this value. And then here's the second slice. The second slice between x equal to 2 and x equal to 3. And so the midpoint will be 2.5. And so again, the thickness or the height of this cylinder would just be 1. And again, to get the radius for this cylinder, we're going to use the midpoint, 2.5. And then go back to the function here. So we do f of 2.5, we get 2 times the square root of 2.5 plus 2. Now f of 2.5 is going to be the distance from the x-axis up to the graph. But the radius that we need is just this part right here. So we're going to do f of x of 2 star minus 4. Minus 4 for this distance right here. That will give us 1.16228. And then the volume for disk number 2 or cylinder number 2 will be pi times the radius, which is 1.16228 squared, times the height of the cylinder or the thickness of the cylinder, which is 1. And that will give us 4.243944. And then here is the cylinder for slice number 3, number 4, number 5, number 6, number 7, number 8. And when we add the volumes of the 8 cylinders together, we'll get 167.2121. And then the sum of the volumes of the 8 cylinders or the 8 discs, this is how we write it using summation notation. I running from 1 to 8. And then this is pi. This is the radius of the ith disk. This is the height of the ith disk, which is 167.21. And therefore, the volumes of this solid of revolution here would be approximately 167.2121. And now, instead of 8 slices, if we divide the solid of revolution into 16 slices, and then find the volumes of the 16 slices, then we'll get 167.46501. And so in this case, r sub x sub I star would be the radius function, which is f of x sub I star minus 4. And then here I will run from 1 to 16. And then here is the volume for 32 slices is 167.5298. And then I will go from 1 to 32. And then here is 64 slices. And then the volume of the 64 cylinders will be 167.5461. And then if we divide the solid here into 100,000 slices, and so we can see that the thickness of each slice would just be 0.000808. And the volumes of the 100,000 slices is going to be 167.5516. And then for 500,000 slices, the volumes of the 500,000 slices will be 167.551608. And then here's a million slices, and this is the corresponding volumes of the 100 million slices. And eventually what we want to do is divide the slices into an infinite number of slices, meaning let n here approach infinity, the number of slices or the number of sub-intervals. And then that will give us the exact solution, the exact volume for this solid right here. And so now let's go find the exact volume. Once again, this is the summation notation that we use for the volumes of 8 cylinders. This is for 16 cylinders. This is for 32 cylinders, for 64 cylinders. And then here we have 100,000, sum of volumes of 100,000 cylinders, 500,000, and then a million cylinders. And then what we want now is we want to find the sum when we divide the solid into an infinite number of slices. And so instead of writing 1 running from 1 to I running from 1 to infinity, we write this as I running from 1 to n with the limit of n approaching infinity. And then once again, f of x sub I star minus 4, this is the ith radius of the ith cylinder. And then when this limit here, when it exists, we defined it as the definite integral from 1 to 9. And then for this particular example, f of x was 2 times the square root of x plus 2, and then minus 4. And then we have dx. The 1 and the 9 here, if we look back at the graph, then we will see the 1 and the 9. So here we have x equal to 1 to x equal to 9. So that's where the 1 and the 9 comes from. And then the function here once again is 2 times the square root of x plus 2. And then simplify here, we get 2 times the square root of x minus 2. And then multiply this out, we get 4x minus 8 times the square root of x plus 4. And then find the antiderivative for each term. Then we get 2x squared minus 16 over 3 x to the 3 halves, and then plus 4x. And then evaluating from x equal to 1 to x equal to 9. So when x is 9, we get 54 pi. And then when x is 1, we get 2/3 pi. And then subtract here, we'll get 160 over 3 pi. And then this is 167.5516. And if we compare this number with the 1 million slices, we see that they're very, very close to each other. So here's 1 million slices, and we get 167.5516. And so the exact answer for this, for the volume of this solid of revolution is 160 pi over 3. And that's the end of the video.